Alright, this lecture is going to work off of the homework paper that I sent out. The homework paper, you'll recall, looks something like this. Let me see if I can move this over. Okay. We need to design a field experiment with 8 treatments, six replicates. We're wide enough that we can go 4 plots wide and we can go 20 plots deep into the field. So we have room for 80 plots where we only need to put in 48 plots, so we should have plenty of room, but we need to make sure that we fit within the dimensions that I described here. Just a little bit about where I'm going to go with this class this semester. We're going to learn how to do some things in SAS. We're going to learn how to design a basic field experiment like the one we're doing today. We're going to talk about why we would use different experiments or different randomizations. We're going to talk about the basic idea behind mean separation and analysis in science. So why do we use ANOVA? How do you do a basic ANOVA? Why don't we necessarily use the basic ANOVA for everything that we do when we're trying to do mean separation? So for this one, I'm going to give you the assignment today. I'd like a copy of it back by next Friday, and it's an opportunity for you to walk through the process of building your own plot layout. Fortunately, I'm going to step through much of this for you today so that you can refer back to this as you get started. If you already know this, then go ahead and get started. You probably don't need to watch the rest of this, but if you're interested in how I would do it, go ahead and stay tuned. I'm going to come over to Excel, and I need to go 20 plots deep, 4 plots wide. So I'm going to go ahead and just outline these plots. I'm going to go to Format Cells, go to Border, Outline, Inside, and this is what the basic plot layout is going to look like. I can tell you in advance that I'm probably going to do 3 versions of this, so I'm just going to put those the outlines for them here. I'll end up using them eventually. The first thing that I like to do is once I have the dimensions that I'm going to put the trial in, I know this is how wide I can go, this is how many ranges deep in the field I can go. I'm going to go ahead and start designing my experiment. Normally I use a few general rules when I'm laying out my trials. One is, with a few exceptions, replicate is going to equal the hundreds place on my plot numbers. So what I would do in this case is this would be rep 1, this would be rep 2, etc. And what I'm going to do then is all of my 100s are going to be in here, and then I simply just number from 101 up to 108, so it would look something like this. You'll see in a second why I'm doing these formulas. Oops. All right, and then for the fun of it, I'm just going to say plus 100. You can type these all out by hand. I don't mind if you do. It's just that, a lot of times it's easier to get accustomed to using shortcuts to speed up the process. Now this is essentially what my plot layout's going to look like in the field when I go out and do my treatments. The 100s are going to be rep 1, 200s are rep 2, etc. And that's good. That's a good starting point, but we still have to find a way to randomize our treatments within each of our replicates here. So I'm going to come over here, and I'm going to put my plot number and I'm going to put my treatment in here, and then I'm going to do the same thing that we did before. You know, I like to use a lot of basic addition to speed up the process here. Oops, I guess it would help if I did plus 100 rather than plus 1. And then I just fill it down until it's to 608 and I'm ready to go. A lot of times, because these have formulas in them, I'll hurry and copy and paste as values just so that I don't have to worry about dealing with formulas after that. But I still need to come up with treatment, and the easiest ways to do this, you know, without getting specialized software or other software, are going to be the following. The first way is pull up Google and go to randomizer.org, or just type in research randomizer. And this is pretty useful because it's a quick and easy way to produce sets of randomized numbers. The number of sets of numbers that I want to generate, in this case, is 6. You put in the number of replicates that you want. The numbers per set are going to be 8, and then it's going to range from 1 to 8. If you put a number range of 1 to 100, you would produce 8 different numbers, but you know, they would be all over the place between number 1 and number 100. We want each number to remain unique because we don't want to duplicate any of our treatments in here, and we don't want to sort the numbers. We're going to randomize them. The cool thing is, if I click download, it's going to go ahead and put it into a CSV file that I can then drop in here, and then it's just a matter of a little bit of cutting and pasting. There are a couple of faster ways to do this, but for purposes of what we're doing here, I'll just cut and paste it here. Something I should have mentioned as I was putting this together is the type of design that I'm putting together here is called a randomized complete block. That simply means that I'm going to have each treatment once within this block that represents a rep here. We'll get into more detail over the semester why we use different experimental designs, but for right now, just keep in mind that we're doing a basic randomized complete block. I would say that generally speaking, this is the most, or one of the most popular research designs for field research. And just like that, now I have my plot number and my treatment number matched up for all of these. It's kind of useful to be able to look at your treatment numbers in the same format as your plot numbers. So I'm going to use a technique called vertical lookup to match up what we have here. What this is going to do is it's going to look in here, find that, okay, this should be plot 101. It's going to come over here and find plot 101. And then it's going to look next to it and say, okay, that must be treatment 6, and it's going to put treatment 6 in here. If you're already familiar with VLOOKUPs, I apologize for the explanation, but I'm trying not to work off of any obvious assumptions here. So I'm going to do a VLOOKUP, going to select the 101 over here first. Then I'm going to come over to this table because this is the one that I'm actually looking up the treatment in. I hit F4 to lock my cells in place, otherwise weird things are going to happen, I promise you. It asks, I don't know why maybe I hit the wrong button. So I locked that in place, hit a comma, and it asks for a column index number. That simply means which column are we looking for the treatment number out of. It's going to be column 2. These are index numbers, so it's like 1, 2, 3, 4, 5. Don't think in terms of P, Q, R, S, T. It'll just be 1 through however many columns wide your data are. Do we want an approximate match or an exact match? In this case, we want an exact match because I don't want to have an approximate match between my plot number and my treatment. I want to know exactly what treatment lines up with that plot. So I'm going to put in false. Usually you use true if you're doing something like gradebook where you're trying to get numbers, between 70 and 80 are going to be a C, or 80 and 90 are going to be a B, that type of thing. Excuse me. All right, so it looks like everything's working properly here. I got a treatment 6 here for plot 101, so that's what it should be. If I did this correctly now, I should be able to just fill over, fill up. Let's do a quick double check here. 607 and 608 are treatments 8 and 2. Come down here, these should better be 8 and 2. They are, so that's good news. Now, one thing that you can do is actually see how many of your treatments happen to just be close to each other. I can tell you already that something pretty funny happened right here between the beginning of, or the end of rep 2 and the beginning of rep 3, in that we got a 3, a 6, a 2, and a 4. Well, no, I guess just a 3, a 6, and a 2 all together. With 6 replicates, I'm not particularly worried about that. If you are worried about it, come back over here, run another randomization, or, move set 3 to set 6. You want to be careful not to bias your randomization by just going in and wholesale changing numbers, but if you don't like what came out of it, you may want to address that. It's better to address it early than it is to to worry about it after you've actually made the trial. I'm going to do conditional formatting. Let me go ahead and maximize this. Conditional formatting, and I'm just going to do color scales, and this is going to show me, do I have any patterns in my coloring here? Like I mentioned, we've got the 3 6s and 2s that are here. We've got a pair of 7s here, a pair of 4s. That is something that you may want to address. If it's not blatantly, if you have a couple of numbers that are next to each other, or a couple of treatment numbers that are next to each other, it's not the end of the world. But if you have a lot of them, it's probably indicative that you need to, run your randomization routine one more time. Would also probably help if I put in rep here. One way you could do this is just, type in 1s for all of rep 1, and then just, add 1 all the way down like so. Another way you could do it is just say, okay, let's just take the leftmost character out of here, equals left P1 and then 1 character. That's also going to give you the 1s through 6s. If you wanted to use a vertical lookup, you could go in and say, this would actually be an opportunity to use a VLOOKUP with a true. So I'm going to look in here. I'm going to look for the value in this table. Hit F4 again to lock the $signs, comma 2, true in this case. And that should also return the same thing, which it does. And so, great. All right, so far so good. It might not hurt if you have someone visiting your fields to be able to give them a plot layout that has both the plot number and the treatment number in it. So I'm going to use the concatenate function to quickly combine these. So I type in concatenate. I want to combine that. I'm going to go ahead and put a dash in here. If you need to enter any text, just put quotations around it. And then I'm going to click on here. Notice I'm not using any dollar signs because I want it to relatively change itself as I'm moving to the right and moving up in here. If I did this right, it should do a 101-6 in here when I hit enter. Oh, good, it did. All right, and just like that, we have a plot map with treatments in it. May not hurt at that point to, that's a little bit skinny, but to adjust your column widths accordingly. The only other thing that I could see that would be nice to have that is kind of a little bit more involved is this color scheme over here. I don't think you can just paste the formats, but let's find out. No, because it carries the format painting here. I think one thing that you can do, at least I think I've done this before, is actually paste it into Word and then delete the numbers out of here and then actually copy and paste the formatting back. Guess it would help if I pasted it in the right place, huh? Let's just do it again. So concatenate 101, put a dash in here, and treatment 6. Fill that over, fill that up, and guess when I fill it over, I better tell it fill without formatting. And then when I fill up, also fill without formatting. There we go. So now we have a cool color coordinated plot map that you can send, take people out to the field with. All right, do I expect you to do all of that for assignment 1? No, not necessarily. Really just, you need to come up with a plot map. You need to put plot numbers in there. You need to have a treatment list with plot number, treatment, and rep. And so, here's your plot map. These are useful, but they're not required. And then here is your plot plan, or your plot plan with your plot, treatment, and rep in here. I don't know if you're going to have access to SAS in what you're doing, but let me quickly show you how I would generate a randomization in SAS. So here's SAS. I'm using an enterprise guide. I've got some instructions at the top of the files that I sent on, why we put stuff in that we use. This is a very simple procedure. I don't have to have any data to run it, and it just produces a randomization. So this is proc plan. The seed represents, if I understand correctly, the total number of values that are going to be pulled into the randomization set. The default was 27,371. I tried it with a few other large numbers, and it didn't seem to be improved or or made worse by how big or how small I made the numbers. I didn't try any really small numbers. So just leave this in here. This will be your number of replicates. I was telling the group earlier, I was going to record this then, but I ran into issues. The replicate is going to be the block, and then what you put after ordered is going to be your treatment within. You can name this anything that you want. I don't know, you can probably name this anything that you want as well. let's say we want this to be block instead. Let's try that and see. And plot doesn't make any sense. Block. Block equals 6, treatment equals 8. When I hit run, it should make 6 blocks with 8 treatments per block, and those treatments should be randomized. Oh, looky here. So I have 6 blocks, 8 treatments per block, and then I would do the same thing that I showed you earlier, where you would just paste it in here, maybe paste in as text rather than as formatted text. And then the only thing I would caution on this is before, when I brought these in, the treatments ran down this way. Now they run across this way. So you will probably want to, turn it around. And I'm just going to do that by doing a transpose paste. And then you can go through the same process of breaking it down. I don't know if you've used macros before, but if you want to speed up the process, you could actually put in a macro here. All the macro does is you tell it what to do, and it does the same thing over and over. So if I did this correctly, whoa, I forgot that I have some shortcut keys associated with the Camtasia Studio, so I may have to change my Control-Shift-E. Let's see what that does. And just like that, you have them laid out in order just like we had over here. So 2 different ways to get your randomization. Either one I'm completely comfortable with. You would go ahead and save this, send it to me before next Friday, and look for further instructions at that time. All right, this is Dr. Ritchie, over and out.